So currently we are in R Studio, and in this video tutorial, we will explain it to you that how you can calculate the two sample independent t-statistics by yourself in R of your data. Currently, we are in a working directory, and in our working directory, we have a one data set plant_length_data.csv. In this data set, we have the two groups data. In a one group, the plants are grown with the traditional methods, while in another group, the plants are grown with the modern methods. Now we want to compare the plant length in both groups by using the two sample independent t-test. To perform the two sample independent t-test, let's first load the data. And to load the data, let's first create a variable and let's name it as a sample_data. After writing down the name of the variable, let's give the sign of equality in R, and after it, we are going to use one very famous function that we have used many times before, and that is read.csv to load your data. After writing down the read.csv, we will give the parentheses, and within the parentheses, we will write down the name of the file that is holding your data. After writing this piece of code, let's run it. And when you will run it, then look at the environment. Our data is successfully loaded. There are total 30 observations and the two variables. And we hope so that now you will be pretty comfortable with the concept of the 30 observations and the variables. Now let's check the structure of this data set. To check the structure of this data set, we are going to use one function str. After writing down this piece of code, let's run it. When you will run it, then look at the console. The console is letting us know that there are the two variables. The one variable name is traditional, while another variable name is modern. And both of these variables are holding the numeric values. We want to compare these numeric values by using the two sample independent t-test. Now let's first check it out that there is a normal distribution of the data in those variables or not. To check the normal distribution of the data, we are going to build the histogram. You can build the density plot as well. So to build the histogram, we are going to use the R-based function HIST. And after typing the HIST, we will give the parentheses. And after giving the parentheses, we will write down the name of the variable that is holding our data. And then we will give the $sign. And after giving the $sign, we will select the variable in which we are interested. Let's first select the traditional. After completing this code, let's run it. And when you will run it, then look at the plot section of your R Studio. In the plot section, you will see the histogram. And this histogram shows that there is a normal distribution of the data. So let's build the histogram for the second variable, which is modern, using a similar piece of the code. When I have run this piece of code, then look at the plot section. In the plot section, now we have the distribution of the modern variable data. Now, this distribution seems to be approximately a normal distribution. It means that we can apply the t-statistics on this data. Now, we want to apply the two sample independent t-test, and as we have told you earlier, that there should be the comparable variance between the two groups, or there should be the homogeneity of the variance. To get an idea about the homogeneity of the variance, we need to apply the Levene test. But before applying the Levene test, we first have to carry out the data format transformation. Before carrying out the format transformation, let's first see our sample data. Now to view the sample data, come to your Environment tab and then click on the sample data. When you will do that, then look at your left-hand side. You can visualize your data in two columns. One is a traditional, while another one is a modern. Now, in this format, we cannot apply the Levene test. We need to carry out the data format transformation. Now, to carry out the data format transformation, we will write down a very small piece of the code which we have demonstrated in a previous video tutorial. Now, what it will be, let's write down here. Now, let's see that how you can carry out this format transformation. To carry out the format transformation, we are going to use one function pivot_longer. This function is available in a library tidyr. So let's first call the library. To call the library, we will write down this piece of code and then we will run it. When we will run it, then look at the console. Our library is successfully loaded. We didn't get any error message. Now, after loading the library, now what we will do, we will transform the format of our data. To do that transformation, let's create a new variable named data underscore longer. After writing down the name of the variable, we will give the sign of equality, and now we will write down the function which will carry out that transformation. The name of that function is pivot underscore longer. After writing down the name of the function, then we will come inside the parentheses, and inside the parentheses, we will write down the name of the variable that is holding our data. And the name of the variable that is holding our data is a sample data. After writing down the name of the variable, we will give the comma, and then we will write the calls. Here we will define the name of the columns in which we are interested. We are currently interested in the two columns name or the two variables name. The one is a traditional, another one is a modern. So let's write down the name of those columns. To write down the name of these two columns, we will first type C and then we will give a parenthesis. And within a parenthesis, we will write down the name of those two columns. After defining the name of the columns, we will come out of the parentheses and then we will give the comma. And after giving the comma, we will write down another argument names2. After typing the names2, we will give a sign of equality and then we will write down the name of the two new columns. As we told you earlier that we want to have two new columns. The first column name will be the group, while the second column name will be the length. So what we will do, we will give the comma inverted comma. After writing down the comma inverted comma, we will write down the group. After writing this, we will come out of the comma inverted comma and then we will give a comma. After giving the comma, we will write down another argument, values2. After writing down the values2, now what we will do, we will actually define the name of our second column that we want to have in a new format. And that column is a length. So what we will do, we will give the comma inverted comma, and within a comma inverted comma, we will type length. Now, after writing this piece of the code, let's run it. When you will run it, then look at the environment tab of your RStudio. In environment tab, you can see the data underscore longer variable is now created. And this variable is holding a data of 60 observations in the two variables. Let's view this data. To view this data, we will just click here. And when we will click here, then the data will be in front of you. Here you can see that there are the two columns. One is a group, another one is a length. We also that now this point will be clear to you now. Now let's come back to the code section, and in the code section, now let's try to apply the Lemony test. To apply the Lemony test, first we need to call the cars library. To call the cars library, we will type first the library, and within the parentheses, you will write down the car. After typing this piece of code, let's run it. And when you will run it, then look at the console. The cars library is now loaded. Now please remember that if you don't have the car library in your RStudio, then please install it. We have already explained it to you that how you can install the new package in your RStudio. After calling the car library, we will write down the name of the function that will carry out the Lemony test. And the name of the function is Lemony. After typing the Lemony test, now we will define the name of the two columns that will have the data. The first column is a length. After typing the name of the first column, which is a length, we will give the tilted sign, and then we will write down the name of the second column, which is a group. Now after typing this, we will give a comma, and after giving a comma, now we will write down another argument named data. After the data, we will write down the sign of equality, and after giving a sign of equality, we will write down the name of the variable that is holding our data. And the name of the variable that is holding our formatted data is data underscore longer. After typing this, we will simply run this piece of code. When we will run this piece of code, then look at the console. In the console, you can see the values of the Lemony test. And in these values, the most important value is a p-value. Now look at it here, Dad. Is this p-value small or large? Indeed, this p-value is quite large. As we have told you earlier that if p-value is large, it means that the variance of the two groups is comparable. And it means that we can apply the two-sample independent t-test. Now in this data, fortunately, we can apply the two-sample independent t-test. Now let's come back to the code section and let's apply the two-sample independent t-test. To apply the two-sample independent t-test, let's call the BSDA library. To call this library, we will write down the library. And after writing down the library, we will come inside the parentheses, and inside the parentheses, we will write down the BSDA. Please load this library. Once you will load this library, then all the functions of this library will be available to you. Now let's apply the two-sample independent t-test. To apply the two-sample independent t-test, let's create a new variable named test. And after writing down the name of the variable, let's give a sign of equality. And after giving a sign of equality, we will write down the name of the function that will apply the two-sample independent t-test, and that is t.test. After typing this, let's give the parentheses. And after giving the parentheses, now let's define the x. And what will be the x? The x is going to be our first group. So to define the x, we will type the x and then we will give a sign of equality. After giving a sign of equality, we will write down the name of the variable that is holding our data. And the name of the variable that is holding our data is a sample data. Now in a sample data, we are interested in a first group, and that group is a traditional. So we will select the traditional after typing the $sign. After defining the first group, then we will give a comma, and then we will type the y to define the second group. And the second group is a modern. To specify that second group, after typing the y, we will give the sign of equality, and we will write down the sample underscore data. After this, we will give the $sign, and we will select the second group of the data in which we are interested. Now, please keep it in mind that in t.test function, we cannot use the longer data type. Now, please keep it in mind that in t.test function, we cannot use the longer form of the data. Now, after defining the two groups, we will give the comma, and after giving the comma, now we are going to define that what type of the test we want to have. We want to have a one-tailed test or the two-tailed test. To define it, we will type the alternatives, and then we will give a sign of equality. And currently, we are interested in a two-tailed test. So that's why we will give the comma inverted comma, and within a comma inverted comma, we will write down the two-sided. After typing this, then we will give a comma, and let's define the level of significance by using an argument con.level. After writing down the con.level and the sign of equality, we will write down the 0.99. Currently, we are interested to perform the two-sample independent t-test at 99% level of significance. After this, we will give a comma, and after giving a comma, we will write down the most important argument of this code, which is var.equal. Here we are going to define in that the variance of the two groups is approximately same. To let the code know that the variance of the two groups is approximately same, we will write down here the true. After typing this, we will come outside the parentheses and we will run this piece of code. When we will run this piece of code, then look at the console. We didn't get any error message. If we didn't get any error message, it means that our t-statistics is successfully calculated. Let's print out the values. To print out the values, we will type the print, and then we will write down the name of the variable that is holding our test values. After this, let's run this piece of code. When you will run this piece of code, then look at the console. In the console, you are going to have the values. The first value is a t-statistics value, which is minus 14.49. Then you are going to have a degree of freedom, which is 58. And after this, you are going to have a p-value. The p-value is 2.2 multiplied by 10 raised to power minus 16. Now, can you guys let us know that is this p-value is smaller than 0.01 or greater than the 0.01? Indeed, this is quite small than the 0.01. Then what does it really mean? It means that our null hypothesis is rejected. We hope so that now you guys will have a good idea that how you can perform the two sample independent t-test in an R studio. Please stay with us. In the next video tutorial, we will talk about the two sample independent t-test.